Hello everyone, I heartily welcome you. I, Gaurang Chapaneri, founder of Mechanical Guru 2020 YouTube channel. In this video, I have covered dual method with maximization and minimization problem of linear programming. If you like my video, then please subscribe it and press the bell icon to get latest notification and don't forget to press the like button. Now I will go to the dual method. In today's video, we discuss the dual method or dual problem. So first we understand the theories, then next we solve the example. Okay, so first convert primal LPP into the dual LPP. So here we have to convert the primal LPP into the dual LPP. So in that we have to follow some steps or some point. Let's see one by one. First of all check the types of constraint. Constraint in LPP must be according to its standard form. If not, then convert it. Means standard form means if the problem is maximization, then all the signs should be less than equal to. If problem is minimization, then all the signs should be greater than equal to. If equal to, then it's fine. In duality, the number of decision variables depends on the number of constraints in the primal. So, if there are m constraints in the primal LPP, then there will be m number of decision variables in a dual LPP. Means it represents the number of constraints in a primal is equal to number of decision variables in a dual LPP. Similarly, the number of constraints in a dual LPP depends on the number of decision variables in the primal. So, if there are n decision variables in the primal LPP, then there will be n number of constraints in a dual LPP. Same thing similarly, number of decision variables in a primal is equal to number of constraints in a dual LPP. Means it represents if our objective function maximize or minimization, in that if there are three variables x1, x2, x3, then so there will be three constraints in a dual LPP. Clear? Now, other important modification is taking place as a given below. So most important first, objective function. If the objective function is maximized in a primal LPP, then it will change to the minimize in a dual LPP or vice versa. If problem is minimization, then dual problem will be maximization. Second, coefficient of objective function. The coefficient of objective function in a primal LPP will be the right hand side of the constraint in a dual means the coefficient objective function means suppose objective function maximize z is equal to 10x1 plus 10x2 plus 10x3. So in that the profit constant that is 10, 10, 10. This we have to write down in the right hand side of the constraint when we convert the problem in dual LPP. Similarly, constraint, the right hand side of the constraint in a primal LPP will function as a coefficient of objective function in a dual LPP. Next, the coefficient of decision variables each constraint. So in that, it's very simple. Just we have to convert the matrix, that is transverse matrix of primal LPP is applicable to the coefficient of decision variables in each constraint for the dual LPP. And there are some other constraint type Okay, so here I will show you. It's very simple. In a primer LPP, okay, and here dual LPP. In a primer LPP, if the constraint type less than equal to type, then dual constraint will be greater than or equal to type. If the constraint greater than equal to type, then in a dual constraint is less than equal to type. The primal constraint I is equal to type. Okay, so in a dual variable yi is unrestricted in a sign, and the last primal variables xj unrestricted in sign. In a dual constraint j is equal to type. Okay, so there are some important modifications when we convert the problem from primal to LPP. Now we will solve the example. Find the dual of the following LPP. Here just we have to convert the problem from primal to dual. Okay, so here the problem is maximize z is equal to x1 minus x2 plus 3x3 subject to x1 plus x2 plus x3 less than equal to 10. Second constraint 2x1 minus x3 less than equal to 2. Third constraint 2x1 minus 2x2 plus 3x3 less than equal to 6, and the non-negative condition, that is x1, x2, x3 greater than equal to 0. Now this problem we converted into the dual LPP. Let's see how to solve. It's very simple. So here LPP is a standard form as shown. So applying the following step to get the dual. The standard form means here all the sign should be same. If the problem is maximized, then all the sign is less than equal to. If equal to, no problem. But if sign is greater than equal to, then we will solve the other example. First, the problem is maximization. The dual problem will be minimization. The number of constraints in a primal is 3. So the number of dual variable is 3. Okay, so here there are 3 constraints. So there are 3 dual variables. Same thing, the number of decision variable in a primal is 3. So the number of constraint is 3. Here there are 3 decision variable x1, x2, x3. So there will be a 3 constraint. In a primal, all the constraint type less than equal to type. So all constraint in a dual will be greater than equal to type. The right hand side of the constraint, that is 10, 2 and 6 will be the coefficient of objective function, and the coefficient of objective function will become corresponding to the right hand side of the constraint. Here all the decision variables are greater than equal to 0 type, so all the constraints will have greater than equal to type sign. Now all the steps we have to apply and we convert the dual problem. So first we convert the problem. Here as per the steps, maximization of the problem is minimization. So minimize z is equal to right hand side of the constraint will be our objective function. So minimize z is equal to 10y1 plus 2y2 plus 6y3. It's very simple. Now here I will show you some of the important tricks. Easiest method to solve the dual problem without any mistake. Okay, so here just we have to prepare one matrix. So in that just we have to write down the technological coefficient. Okay, so here the first equation, just write down the technological coefficient. So 1, 1, 1. Okay, here all the sign is plus positive. Okay, in second constraint 2, x2 0 and x3 minus 1. So 2, 0, minus 1. And the last 2, minus 2 and 3. Here now here we convert the problem. So here just simple follow this arrow direction. So when we convert in a primal to dual, in that we have to follow the transverse matrix. So in that just we have to prepare the matrix so you can easily solve the problem. So just simple here, y1 plus 2y2 plus 2y3. Similarly, second, y1 plus 0y2 minus 2y3, and the last, y1 minus y2 plus 3y3. Clear? Next, here all the sign is less than equal to, so here all the sign is greater than equal to. Simple. And the next, we have to write down the right hand side of the constraint. So in that we have to go to our objective function, maximize z is equal to x1 minus x2 plus 3x3. So here the profit constraint is Cj 1 minus 1 and 3. Here all the sign is greater than equal to 0. So here y1, y2, y3 greater than equal to 0. See, here the example is finished. Simple. Within 2 minutes you can solve the example. Now we will solve other example. So here the problem is minimize. Minimize z is equal to 7x1 plus 3x2 plus. Here the problem is minimize. Minimize z is equal to 7x1 plus 3x2 plus 8x3. Subject to first constraint 8x1 plus 2x2 plus x3 less than equal to 3. Second, 3x1 plus 6x2 plus 4x3 greater than equal to 2. 4x1 plus x2 plus 5x3 greater than equal to 6. And the last constraint x1 plus 5x2 plus 2x3 greater than equal to 7, and the non-negative condition x1, x2, x3 greater than equal to 0. Now we solve the problem. Here as per the step, here the problem is standard form. Here all the sign is greater than equal to. Okay, so here LPP is a standard form as well. So now convert it into dual problem. Now here I will solve directly. So here problem is minimized. So maximize z is equal to 3y1 plus 2y2 plus 6y3 plus 7y3. It's simple. 7y4, sorry. Now we prepare the matrix. Okay, just we have to write down the technological quotient, that is 8, 2, 1, 3, 6, 4, 4, 1, 5, 1, 5, 2. Clear? And now just convert it. Okay, so first equation is 8y1 plus 3y2 plus 4y3 plus y4. Clear? Second, 2y1 plus 6y2 plus y3 plus 5y4. And the last, y1 plus 4y2 plus 5y3 plus 2y4. Clear? And here all the sign is greater than equal to type. So in a dual problem will be less than equal to type. And objective function profit constraint you have to write down here, that is right hand side of the constraint. So 7, 3 and 8. And non-negative condition, that is y1, y2, y3, y4 greater than equal to 0. Okay, so here example is finished. Now we will solve other example with different category. Minimize z is equal to 3x1 minus 2x2 plus 4x3. Okay, and here are the constraint. So here all the constraint is greater than equal to, except one sign is less than equal to. So in that means it's represent our problem is not in a standard format. So first we have to prepare the standard format, then convert to dual problem. So in that what we have to do, just simple. This equation we have to multiply by -1 in both sides. Let's see how to solve it. Here LPP is not in a standard form, so first convert it, then generate in the dual. So as per the same, minimize z. Okay, just go to the third equation. here in this equation just multiply by -1, that is minus 7x1 plus 2x2 plus x3 greater than equal to minus 10. Okay, and the remaining equation as it is, just we have to write down. Clear? So here the problem is standard format. Now this problem we have to convert into dual problem. So here maximize z is equal to 7y1 plus 4y2 minus 10y3 plus 3y4 plus 2y5. Simple. Next we have to prepare the matrix. So 3, 5, 4, 6, 1, 3, minus 7, 2, 1, 1 minus 2, 5, 4, 7, minus 2. Okay, just we have to write down the technological coefficient. And now this matrix we have to convert in the transverse matrix. So the first equation 3y1 plus 6y2 minus 7y3 plus y4 plus 4y5. Simple. Similarly second 5y1 plus y2 plus 2y3 minus 2y4 plus 7y5. And the last 4y1 plus 3y2 plus y3 plus 5y4 minus 2y5. Clear? Here all the sign is greater than equal to. So here all the sign is less than equal to. Okay. And our objective function, the profit 3, minus 2 and 4, it is the right hand side of the constraint in a dual problem. So here 3, minus 2 and 4. And the non-negative condition, that is y1, y2, y3, y4, y5 greater than equal to 0. Okay, it's simple example. Within a 2 minutes you can solve. Let's see one more example. Okay, same example here, just sign is different. Okay, the problem is minimized. So here the sign is greater than equal to, less than equal to, and equal to that. So first we have to convert the standard form. So here same, the third equation sign is less than equal to. So first we have to convert it into the standard format. Okay, minimize z, third equation same, multiply by -1 on both sides, remain equation as it is. Okay, so here the problem is standard format. So here we convert it, maximize z is equal to 9y1 plus 5y2 minus 10y3 plus 4y4 plus 3y5. Clear? Next we have to convert the matrix 3, 4, 6, 1, 3, 2, minus 7, 2, 1, 1, minus 2, 5, 2, 5, minus 3. So the first equation 3y1 plus y2 minus 7y3 plus y4 plus 2y5. Similarly second and last. Clear? Here all the sign is greater than equal to except last sign. So here we have to write down all the sign is less than equal to. And next we have to write down the right hand side of constraint, that is our objective function profit Cj value 5, minus 6 and 4. So here the last equation sign is equal to type. So it's represent y5 is unrestricted sign. Okay, so y1, y2, y3, y4 greater than equal to 0 and y5 is unrestricted in sign. Here thank you everyone for watching my video. For a query or suggestion you can contact me. This is my mobile number and this is my mail ID. Once again, thank you everyone.